Hi, thanks so much for joining us today. We're going to talk about best practices for grade 4 prime and composite numbers. My name is Bailey. So before we get started, I want you to look at this picture. There are some prime numbers written on the board. We have 2, 3, 5, 7, 11, and 13. And somebody makes a wonderful comment of, and those ship free, right? And maybe that's what you think of when you hear prime, because I definitely think of those lovely packages coming to my house. But today we're going to talk about what a 4th grader should know when they think about prime and composite numbers. For this unit, prime and composite numbers, there are two major key learnings. The first is that students should be able to use their multiplication knowledge as arrays and areas of rectangles to determine the factor pairs of numbers 1 through 144. So if you look at the picture on your screen, you can see that the number 16 has been arranged in multiple ways using these red dots, and they show different arrays. Students should then use this knowledge of factor pairs to determine if a product is prime, composite, or neither. Since the number 16 has multiple factor pairs, we are able to say that this number is composite. What does student learning look like in the classroom? During this unit, students will be given real-world situations, and they'll be expected to use concrete tools to model the situation in the problem. They'll then move to creating representations using drawings, graph papers, and T-charts to find all factor pairs of numbers between 1 and 144. This information will then be used to determine if the number is prime, composite, or neither. The MTRs throughout this unit are going to be 1, 2, 5, and 7. What does student learning sound like in the classroom? If we were to ask students this question, does the orientation of the rectangles matter? Is a 2 times 6 rectangle the same as a 6 times 2 rectangle? We would expect students to be able to explain that the two rectangles do show the same product, but they have two different arrays. One is showing 2 rows of 6 and the other is 6 rows of 2. However, if we were to turn either of those arrays, it would turn into the other array. The second question is, how do the factors relate to the product? We'd want students to explain that the factor pairs can be multiplied together to get the product. A factor times a factor equals a product. Is the number 1 prime or composite? This is where students need to understand that a prime number has two factors. That's 1 and itself, and then composite numbers have more than one factor. However, the number 1 doesn't fit into either group, so it is actually neither. And the last question we have is, are all even numbers composite numbers? This is a really big misconception students tend to have because they assume all even numbers are composite. However, the number 2 is even, but it is the only prime number because the only factors it has are 2 and itself. The MTRs throughout this questioning is going to be 1, 2, 4, and 5. Throughout this unit, there's a lot of new vocabulary that students should be using throughout their discussions and even their written responses. Students should be able to describe these words and give examples of the following: composite number, digit, factor, factor pairs, multiples, prime number, range, and whole numbers. How will students demonstrate their knowledge? Throughout this unit, students will be able to represent a product in multiple ways, finding all the factor pairs for numbers between 1 and 144, and they'll move through the use of concrete tools, drawings, which include the rectangles or even graph paper, and then other representations such as a cheat chart and equations. Once students have developed this understanding of how to find all factor pairs, they'll start to determine if a number is prime, composite, or neither based on the number of factor pairs. Students can play this game from STEMscopes to demonstrate their knowledge, and it's called Prime and Composite Match. In this game, students are given a set of cards and asked to make matches of composite numbers with possible factors. So for example, the number 5 could be matched with the number 45 because 5 is a factor of the number 45. At the end of the game, students are expected to find more factor pairs of their given number. The MTRs throughout this unit are going to be 1, 2, 5, and 7. Here are some questions to gauge student understanding. The first is, what is a factor pair for the number 24 and how do you know? Students should be able to explain that a factor times a factor gives a specific product. So students should be able to give some of those examples of factor pairs that you can see on your screen. They should understand that when we're multiplying those expressions, the product is going to be 24. The second question is the number 36 prime or composite, and how do you know? Students should be able to use concrete tools, drawings, equations, or T-charts to show all the factors of 36. You can see them listed on your screen. Since the number 36 has more than one in itself as factors, it is a composite number. Determining if a number is prime or composite is a skill that could be easily practiced at home. Students can find any objects around their house and they can create arrays using those objects. So the example on the screen shows 12 cars and they're set up in an array showing 4 rows of 3. The cars could then be moved around to show 1 row of 12, 2 rows of 6, and so on. Students can then determine if the number is prime or composite. We know that this number is composite because we're able to arrange it in multiple ways. The MTRs throughout this activity are 1, 2, 5, and 7. Thanks for taking the time to join us today to talk about 4th grade prime and composite numbers. We'll see you again next time.